So today we're going to talk about solving three variable systems. We've been working on two variable systems, so we're going to take it up a notch. Mainly what we're going to do today is use substitution to solve these systems. So the first two are going to start us off nice and easy. If you look at that first system, it's got three variables in it, x, y, and z, but they've already kind of helped us out because they've given us that z is equal to 4. So once we know that z is equal to 4, we can take that 4 and put it in that second equation where all we have is y plus z equals 7. So that tells us that y plus 4 is equal to 7, so that y has to equal 3. Now that we have y and z, we can plug in for y and z into our first equation. So x plus 3 plus 4 is going to be equal to 12. So that's going to give us x plus 7 is equal to 12. So x is equal to 4. Now the way that we are going to write our final answer, sorry, my dog's barking in the background. The way we're going to write our final answer is as an ordered triple in the order of x, comma, y, comma, z. Oops, sorry. 12 minus 7 is not 4. 12 minus 7 is 5. Sorry about that. So now the way we're going to write our answer is as an ordered triple, x, comma, y, comma, z. This ordered triple represents a location in a three-dimensional grid, or a three-dimensional graph with an x-plane, a y-plane, and a z-plane. So that's something that you'll see when you get closer to calculus in college. All right, let's look at number 2. Our first step on number 2 would be to go ahead and solve for z, since it's given to us so nicely. If we divide both sides by 3 here, we're going to get that z is equal to negative 1. Once we have that z is equal to negative 1, we can take that and plug it in to our second equation. So if 2y minus negative 1 has to equal 7, that means 2y plus 1 equals 7. So 2y equals 6, and y equals 3. Lastly, we'll plug in for x into our final equation after plugging in for y and z. So that's going to give us 2x minus y, which is 3, plus 3z has to be equal to negative 2. So it's going to be 2x minus 3 and a minus 3 are going to give us minus 6. So 2x equals 4, so x is going to be equal to 2. And again, you're going to write your final answer as an ordered triple, x, comma, y, comma, z. All right, let's look at number 3. Number 3 is going to be an application problem using 3 variables. So we're going to write our system, and then we are going to find these 3 numbers that fit these requirements. And actually, if you notice that our question asks us to find the product, so that's what we'll be doing at the end. So the first thing we have to do is we have to write our system. If we have 3 numbers, that means we have 3 variables. Sum of these 3 numbers is negative 4. So remember, sum means that we can add. So I can have x plus y plus z is equal to negative 4. The second number, so that's y, decreased by the third, so y minus z is equal to the first, so equals x. The sum of the first and the second number is negative 5. So x plus y equals negative 5. Okay, so what we're going to do is, if you'll notice, this equation right here already has x isolated. So in both of our other equations, we are going to plug in for x. So let's see what that's going to look like. I'm going to replace x with y minus z. So y minus z plus y plus z is equal to negative 4. So this was us plugging in x. And down here, y minus z plus y is equal to negative 5. Now, this works out quite nicely because if we reduce both of these equations, we're going to actually be able to solve one. So what we've been doing here is we've been creating a system now that only has 2 variables because we can solve that. So y and y is going to give us 2y. Negative z and positive z gives us 0, which is really nice because that's going to let us solve for y. Down here, we're going to have 2y minus z is equal to negative 5. So this is like a new system. But we know that right here, we can go ahead and solve for y. Y would be equal to negative 2. Once we are able to find what y is, because we have this simplified equation here of just y and z, we can go ahead and solve for z. So 2 times negative 2 minus z is equal to negative 5. So negative 4 equals negative 4 minus z equals negative 5. So negative z equals negative 1. So z equals 1. Now that we have y and z, we can come back over here and we can solve for x because we have x as a relationship between y and z. So take these and come on back over here. If we know that x equals y minus z, that means that x is equal to negative 2 minus 1. So x equals negative 3. Okay. So we've got our 3 numbers, and if all they were asking for was our 3 numbers, we would list those out. But instead, if you'll notice in the problem, we are asked for the product of the 3 numbers. So to get the product, I multiply. That's negative 3 times negative 2 times 1, which is going to give me a positive 6. So my final answer here is positive 6. The reason I'm asking you for something like the product, or what the first number is, something like that, is that's how it's going to be asked on PSATs or ACTs, things like that, so that they don't just give you all 3 answer choices, because otherwise you could just go ahead and plug them in. All right, so let's do one more problem here. We are given a triangle, and we are told that that triangle has a perimeter of 65 feet. All right, well, what do we know? Or we know that perimeter is when we add up all the sides. So I'm going to take my just general sides, L, M, and N, and I'm going to add those up. So L plus M plus N is equal to 65. Then I get my other 2 equations, because I have 3 variables, so I have to have 3 equations from my picture. L is equal to 1/3 M, and N is equal to L plus M minus 15. All right, so we've got L and N both isolated here. It doesn't matter which one you pick. I always pick the one that looks a little bit easier, and to me, L equals 1/3 M is a little bit easier to plug in than all of this. So what I'm going to do in both the other equations, I'm going to replace L with 1/3 M, like I see here. That is creating a new system in only 2 variables. So L is 1/3 M plus M plus N equals 65. And then that bottom equation, N is equal to L is 1/3 M plus M minus 15. All right, I'm going to go ahead and reduce both of these equations, or simplify both of these equations. 1/3 M plus M. Remember, we can think of 1M as 3/3M, 3/3. So that's the same as 1. So 1/3 M plus 3/3 M is 4/3 M plus N equals 65. second equation is going to turn into n equals 4/3 n, or sorry, 4/3 m minus 15. All right, so what I want you to notice is that we have created a new system in only two variables, m and n. And now we can use substitution, elimination, whatever we want to solve this new system of only two variables. So in my opinion, substitution is set up very nicely here. I've got that n equals 4/3 m minus 15. So I'm going to take that and I'm going to plug it in right here for this n. So that's going to give me 4/3 m plus, instead of n, I'm going to plug in 4/3 m minus 15. That's going to give me 65. Okay, 4/3 plus 4/3, that's going to give me 8/3 m. If I add 15 to both sides, I'm going to get 4/3 m is equal to 80. Sorry, 8/3 m is equal to 80. To get rid of that 8/3, I'm going to multiply both sides by the reciprocal, 3/8. I do that so that these will cancel. 3's and 8's both cancel. So m is equal to, think about it, 8 goes into 8 one time, 8 goes into 80 10 times, so 10 times 3 is 30. So we just found that m is equal to 30. So L is equal to 1/3 m, so that's 1/3 times 30, which would tell us that L is equal to 10. And n is equal to 10 plus 30 minus 15. So that's 40 minus 15, which is going to be that n is equal to 25. I'll double check my work, add all these up, and I make sure they add up to 65, which they in fact do. So those are my side lengths of my triangle. And that is all your notes.